The 21st element on the periodic table of elements is scandium. This is Norris Teaches Science with me, Mr. Norris. This is another physical science edition video. Today we're going to talk about balancing chemical reactions. So your goal of this video is that you can balance chemical reactions so that it observes the law of conservation of matter. So how do I balance a chemical equation? Well, these are kind of guidelines. It's better just to see the examples. But the first thing you do is you have to identify the elements present. You're going to count how many atoms are on both sides of the arrow. Remember, the arrow divides the equation in half. You're going to be placing those big numbers in front of compounds so that it multiplies to the subscripts. You're going to recount atoms on both sides to see if they're equal. And if they're not, you're going to keep adjusting the coefficients so they do become equal. So let's do our first practice. So the first thing I do is I divide the equation in half so I can know where my two sides are. And the half is at the arrow. Then I identify the elements on both sides. On the left side, I see a Cu, and I do a Cu equals, and then I do an O equals. On the other side, it should be the same symbol, same elements. So I do Cu equals and O equals. Always write them in the same order on both sides of the arrow, so it's easier to just look across and see if they're equal. All right. On the left side, let's look at Cu. How many do we have? We have 1. And how many O's do we have? We have 2. On the right side, we look at Cu. We have 1. We have 1 O as well. Then we look, are the numbers equal for both things? No, O's aren't equal. So that's where you're going to start. You're going to try to get your O's equal. So on the left side, you have 2. On the right side, you have 1. You go on the side that has the least amount. We need a number that we can place in front of the compound with the O that can be multiplied by 1 to get to 2. And that would be a 2. We place a 2 here. The 2 is going to go to the O, making the O 2. But remember, those big numbers in the front go to everything behind it. So that 2 is also going to go to Cu. I would draw these arrows while you first start this out with balancing. So that means Cu is 2. We got our O's balanced, but are our Cu's still balanced? They're not. So now we have to look. On the left side, there's 1. On the right side, there's 2. So we go to the side that has the least amount, and that's on the left side. We have 1, but we need 2. What number can you place in front of Cu to multiply by 1 to get to 2? I hope you said 2. That 2 goes to the Cu, making it 2. Then we have this plus sign. Plus signs stop coefficients. It's the only thing that do. Now we have to look. Are Cu's equal? Yes. Are O's equal? Yes. But we have this empty spot here. When you have everything equal, but you still have empty spots, you're going to write the number 1. Usually chemists leave it off because they're lazy and it's just an understood one. But while balancing, just go ahead and place the 1 so it's easier to understand. All right, let's do our second one. All right, here we go. What divides this in half? We have the arrow. On the left side, we have an N equals, an H equals, and an O equals. We don't write these numbers here. Those are for later. We just write the symbols. Do we have the same symbols on the other side? Yes, we do. So we write them in the same order so you can just look across. All right, to the left side, how many N's do we have? 2. We have how many H's? 4. We know that because that's a little number here next to the H. And O, we have 2. All right, on the other side, how many N's do we have? 2. How many H's do we have? 2. How many O's? 1. All right, then we look. N's are equal. Let's not mess with those right now. May have to later, but not right now. H's are not equal. The left side has 4, the right side has 2. So we go on the right side because its number is lower. We need a number that we can place in front of the h that can multiply to its 2 to get to 4. 2. That 2 goes to the h2, making h is 4. But big numbers go to not just what's right behind it, but to everything behind it. So that 2 is going to go to the O as well. And so that's going to give us 2 O's. All right. Now let's look. Is everything equal? N's are still equal. H's are now equal. O's are now equal. Everything's equal. So what would go into the blanks? Ones. Because ones just keep everything the same. And so this equation is now balanced. All right, last balancing question. This one can get tricky. So what divides in half? The arrow. So we divide. Then we write our symbols. We have K, we have CL, and we have O. We have the same symbols on the other side. So we write them in the same order. If you didn't have the same symbols on the other side, this equation would not be able to be balanced. All right. On the left side, on the reactant side, how many K's? 1. How many CL's? 1. How many O's? 3. On the right side, how many K's? 1. How many CL's? 1. How many O's? 2. All right. Now, if you didn't notice, we can only place whole numbers in the blanks. And I'm saying that for a reason. The only thing not balanced are the O's. We need to start with the O's, and on the right side, the O's are the smallest. But is there a whole number that we can place in front of O to multiply by the 2 to get to the 3? I hope you said no. And there's no whole number times 3 to get to 2. When this happens, you're looking for a number that they both can share. 2 times 3 is 6, and 3 times 2 is 6. So your goal now is to get O to be to 6. So what number can you place in front of the O on the right side to get it to be 6? 3. 3 times 2 equals 6. On the other side, what number can you place in this empty spot that you can multiply to the 3 to get to 6? You place a 2. The 2 goes to the O, 3, making it 6. Remember, the number in the front goes to everything behind it until it reaches an arrow or reaches a plus sign. So the 2 goes to the CL, and it goes to the K, making CL2 and K2. O, they're balanced, but are K and CL balanced? No. K is not, so on the right side, it has a smaller number. We need a number that can go in front of K, that can multiply by 1 to get to 2. Hope you said 2. That 2 goes to the K, making it 2. The 2 is also going to continue going to everything behind it until it reaches a plus sign or an arrow. And so it goes to the CL, making it 2 as well. Now we reach the plus sign, we stop. Now we check. Are K's equal? Yes. Are CL equal? Yes. Is O equal? Yes. Are there empty spots? No. So your equation is now balanced. But why do we need to balance equations? It's because of the law of conservation of matter, which states that matter cannot be created nor destroyed. It can be changed, but it can't be created, it can't be destroyed. In other sense, the amount you start with must equal the amount you end with. So if you start with 27 oxygens, you need to end with 27 oxygens. They just can be in different compounds. The amount of them have to be the same. And I hope you learned something about balancing today. This is just something that you just need to keep practicing and practicing and practicing. But I'm Mr. Norris. I'm out for this video. See you in the next one.